Hello everyone, so it is me again Shikha from Technical Cloud Knowledge and I greet you from our side. I hope you all are doing well. So today I'm back with another lecture on Linux and this is the lecture number 36 of our Linux series. So today we will going to continue with the part 5 of storage management and under this topic we will going to move forward with the LVM concept. If you do remember that on my last lectures, I have discussed regarding the storage management a lot, as well as I have also discussed with you that how you can create partitions of a hard drive by the traditional way as well as by the LVM concept. Okay, so today we will going to move forward with the LVM concept with lab 2. So for that, I recommend you all that you must watch my entire video so that you will not going to miss any important detail as the lecture is very important, and if you miss this lecture, that it will be a great loss for you. Okay, so let's start the lecture with the LVM concept. So let's understand the LVM concept first, as I've already discussed with you, but today I'm going to give you a brief as well so that you will be able to revise it. Okay, so what does LVM means? So LVM partition method known as logical volume manager. It is basically based on the virtual method. Okay, in this we do not need to do whatever we do in the traditional way, like first we need to buy the hardware from the market, then after that we will set up a hard drive on that, and if we want to create partition we will do it on a manual based. Okay, but today we will going to move forward LVM concept in which we will going to cover all these things automatically. This will based on the automation tools. Okay, it is a kind of a virtual partition method, logical volume manager. So today we will going to see this concept. So what happens under LVM concept? What we need to understand that suppose there is a hardware. Okay, this is a hardware on which you have set up a hard drive which is about 2 GB. Okay, so how much it is? It is about 2 GB hard drive. Now under the LVM concept, what we need to do, we do not need to create partitions of this hard drive directly because we can't able to extend it. So LVM concept allows you to extend the size of your partitions. That's why we need to create this hard drive into a virtual hard drive which is known as PV. What does it known as? PV. PV refer for physical volume. So we will going to convert this hard drive into a physical volume which is a virtual hard drive. And we are converting this hard drive which is of 2 GB into a physical volume. So your physical volume is also about 2 GB. Okay. After that, what we need to do? After that, we need to create a VG. VG refers for volume group. It is a kind of a container. So it refers to a volume group VG. Okay, which is also about 2 GB. As we have add our PV into this volume group, we will going to convert our PV and add this PV into our volume group. So that's why our VG size is also about 2 GB. So it has also the volume of 2 GB. So that's how we will going to create a container. After that, you need to create partitions from this VG as we are doing under the traditional way. What we were doing, we will creating the partitions by just the directly by just the hard drive. So as this hard drive in the traditional way, what we are doing, from this hard drive we are directly converting the partitions. We are directly creating the partitions, but under the LVM concept we will create the partitions, or should I say LV, from this volume group. Okay, and if the volume group size get extended, you can create up to how much LV you want to create till that volume, till that value. Suppose your volume group is about 500 MB. So you can create LV until 500 MB will be used. After that, you are not able to create any LV, or should I say partitions. So we can create LV from this volume group or partitions, also known as partitions. Okay, so if you want to create your LV about 500 MB, you can create. You can also create, still you can create 1900 MB partitions. Okay, or should I say LV. After that, what we need to do under LVM concept, we need to format this LV, as we are able to know that after creating the partitions, we need to format this partition with some of the file systems. So we will going to format this LV from some of the file systems. Suppose I am formatting it by the ext2 file system. After that, you can mount up this LV from any of the application or the directory. So that's how the concept would work. Okay, so that's how this concept will be work. Now we will going to understand this concept by the lab, so that you will able to understand this in a better way. So let's open the VMware workstation. Log in with your root username. Now, so first we will going to understand how we will going to create PV from a hard drive. So as we all know that we need to execute lsblk command to check that our hard drive has been set up on our system or not. So as you can see, my hard drive SDB has already been set up on my system, because I already discussed with you how you can set up a hard drive on your system. That's why I've already done this process. Okay, so now what we will going to do, we will going to convert this hard drive into a PV. How we can do so? So for that, first we need to check that our LVM package is installed on our system or not. To check the LVM package, you need to execute the command called rpm query LVM2. So as we can see, we are able to get the output, and this is the version of LVM package. So as we are able to get that our LVM package is already installed. Now what we will going to do, now we will simply going to create PV of this hard drive. So execute the command PV create. After that, you need to give the hard drive name SDB. So as you can see, the output which we are getting is that physical volume def SDB successfully created. So your PV has been created. Okay, to check it, you can run or execute two commands. PVS is also referred to check that your PV has been created or not. As you can see, dev SDB has been created into a PV, and it is a LVM2 concept, and it has the size of 20 GB. Okay, you can even execute the command PV display. It will give the output in more detailed way. As you can see, it will also provide you the PV name. We haven't yet provided, so that's why there is no PG name. PV size, alloc table, PE size, all these things you will get by executing PV display. Similarly, now we are able to execute, or we are able to create PV. Now we will going to convert this PV or add this PV into a volume group. So for that, you need to execute the command VG create, provide a name to your VG. Suppose I'm providing my VG. After that, write the PV name dev SDB. So as we are able to get the output, my VG is already successfully created. To check it that it has been created or not, you need to execute VGS. As you can see, so my VG, this is your VG volume group. Under this, there is one single PV has been already there. Okay, and LV we haven't yet created, that's why it is not showing. We can even execute the command VG display. See, all these things which we are getting in a more detail. Similarly, now we will going to create a LV, or should I say a partition, from this volume group. So to create the LV, you need to execute the command LV create hyphen capital L. Here capital L is referring for the size. How much the size you want to provide to your partition. Suppose I'm saying that create a LV which is about 500 MB. After that, you need to provide a name to your LV. Suppose I'm saying LV1. I'm providing the name LV1 to my partition. After that, you just need to write the VG. That under from this VG, just create this LV. So your logical volume has been created. Similarly, you can execute the command LVS to check it, as well as you can even execute the command LV display to check it in more detail that your LV has been created or not. So as you can see, LV path is def under my VG. There is a LV name, LV exists. This is known as LV1. LV name is LV1. Volume group name it's my VG, and its UUID is there. LV access, we have assigned the permission read and write. Okay. creation time, it has also been providing you the creation time. LV status is available. LV size is 500 MB under. We will going to understand these things in further lectures. Okay, so you do not need to come under that much below. Just understand these main things, like what is your LV name, what is your LV path, and what is the volume of your LV, how much size of your LV has been. Okay, so that's how you just need to understand. So as we are able to understand that we are able to create the PV, we are able to convert into a volume group. After that, we are able to create a partition from this volume group, which is known as LV, logical volume. Now it's time to format our LV. To format our LV, we need to execute the command. First, let's execute the command blkid to check is that it has been able to provide assigned with a file system or not. So as we can see, right now LV1, there is no LV1 is there. Okay, so first we need to format it with some of the file system. Suppose I'm providing the file system ext2 to my LV1 partition. So for that you need to execute the command mkfs dot, after that whatever be the file system you want to provide, then your LV path. Under my VG there is a LV name. Okay, so we are able to provide a file system. We can execute the command blkid to check it properly. So as we are able to see, let me set it. Okay, so as we are able to see, under dev, under my VG, there is a LV name LV1. It has been able to provide a file system. UUID is that, and the type of the file system is ext2. Okay, so that's how we are able to provide a file system to our LV. Now it's time to format. Now it's time to mount up this LV with some of the directory. So for that we need to create a directory called, let me create it, cloud. Okay, our cloud directory has been created. We will going to mount up it in a permanent way. So for that you need to come under a directory etc. Under this there is a file called fstab. Just come under this directory by using the vim command. See, here we are able to come. Now you need to do the entry of your LV. Under tab there is a volume group myVG, and under myVG I have created a LV name LV1. Second field, you need to define your mounting point. So I have mounted this LV with the cloud directory. After that, you need to assign your file system, whatever be the file system you have provided to your LV, you need to define here. So I have provided the ext2 file system. The fourth field, it will be referred to your defaults permission. After that, your fifth field, backup and the checkup of your file system. Just save the changes. Just refresh it by executing mount -a or reboot your machine. Now execute df-h command. See here. So we are able to mount it up with some of the directory called cloud. So that's how we will do this method. That's how this method LVM concept will work. Okay, that's how we are able to convert a hard drive into a PV. After that we are able to add it into a volume group. After that we have created a partition called LV, which is about 500 MB from this volume group, and then we have format this, and then we will able to mount up it in a permanent way by the directory called cloud. Okay, so I hope you are clear with that much. Now it's time to understand how we can extend the size of our LV. But before moving with this option, let me tell you one more thing. As you are able to know, here we have used the ext2 file system. Now I am also going to create another LV, but I'm going to create this LV with another file system, which is XFS, because in extended option you will able to see some same changes. Okay, so let's create another LV which is of file system. We're going to provide a file system of XFS to this LV, which we will going to create here. Okay, so to create another LV you need to execute the same command again, LV create -capital L, provide a size value. I'm saying again create a LV which is about 500 MB, then just provide its name. So I'm saying LV2, and it will be created from this volume group which is known as myVG. So your LV has been created You can check by LV display or LVS. See, your LV has been created. Okay, now it's time to format it with some of the file system. So that you need to execute the mkfs command. After that, provide your file system xfs and your LV path, myvg and LV name too. So we are able to provide it a file system which is known as xfs. You can even check it by executing blkid command. See, LV2. Okay, with the file system called xfs, and your LV1 with the file system of ext2. Now we will going to create another directory for this LV as well, so that we can mount it with some of the directory. So I'm going to create a directory called knowledge. Okay, let's mount it up by the permanent way under fsf5. Just do its entry. Write the LV path, LV name, your mounting point, file system, permissions, backup and the checkup file system. Just save the changes. Refresh it by executing mount -a or reboot your machine. I think I have done a mistake. Knowledge. Let me check it. Maybe in the okay, I got it. What mistake I have done? See, here I have written LVM. It should be LV. Sorry for the mistake. It should be LV2. Just save the changes. Mount -a, df-h. See, here we are able to mount it up with the directory called knowledge. Now it's time to do other thing. Now it's time to extend the size of these LV. Suppose if I want to extend the size of my LV1 as well as LV2, how we can do so? So for that you need to execute the command, but first let me clear the screen. So for that you need to execute the command called LV extend, provide the size how much you want to extend. So I'm saying extend 500 MB more in my LV1. Just define the path. So what is showing? Your size has been successfully resized of your LV. You can check it by executing lsblk command. See here 1000 MB. But if I do check it in a permanent mode by executing df-h command, it will not going to provide me the changes what I have done. So as you can see here, LV1 size is still 457 MB. It is not come or it is not extended. So for that you need to execute a command called resize to fs and your LV path. Now you can execute df-h. So as we are able to see, the size has been extended. Okay. So now we will going to extend the size of our second LV, which is LV2. So for that you need to execute the command LV extend -L and provide the size value. So I'm saying again extended size also to 500 MB and your LV path. So you can execute lsblk command to check this. So as we are able to extend, as we are able to extend its size. Now to check it permanently, we will going to execute df-h. Here the size has not been extended. Here we do not need to execute the same command, which is resize to fs. Here we need to execute the command called xfs because we have executed or assigned this file system. That's why we need to execute this command. After that, grow fs and your LV2 path. Okay, so As you can see, your data blocks has been changed, which means your size has been extended. You can execute df-h command to check this size. Okay, as we are able to see, so our size of our LV has been extended. So that's how we will able to extend the size of our LVs. Okay, now if you want to extend the size of your VG, how you can do so? So for that, what you need to do, you need to create, or we can say, or we need to set up another hard drive. Then we will going to convert this into a PV. Okay, so for that, to set up another hard drive, here we need to go under settings, then add a hard drive, next, finish. Okay, then press OK. Just reboot your machine. So you need to use this command like that. Okay, till the time it is being booting up, let's take. So as you can see, it has been boot up. Now let's open our terminal by login with the root user. So now what we will going to do, we will going to log in our terminal, execute genome-terminal, maximize its screen. So now what we will going to do, as we are able to extend the size, now it's time to extend the VG size. So first we need to execute lsblk command to see that our another hard drive has been set up. So as we can see, now what we will going to do, we will going to convert this hard drive into a PV. So for that, you need to execute the command pv create your hard drive name dev sdc. Okay, so as you are able to understand that our PV has been created by executing vgs command or vg display. So as we can see, okay, we will going to add on this PV into our volume group, so that we will able to extend the size of our volume group. Okay, so for that, you don't need to execute the same command. You need to execute the command vg extend dev my vg sdc. Wait, dev, well, first you need to write my VG name, and then here you need to write your hard drive. So you can execute the command vgs to check its size. So as you are able to know that our VG size is now, it is almost about, which is 40 GB. So 2020, which means one hard drive which is of 20 GB, and the other hard drive which has been set up to extend the VG size, it is also of 20 GB. So both made the VG is about 40 GB. Okay, so that's how we are able to extend the size of our VG, which is volume group. Now the last thing which we will going to cover in our lecture is that how we can reduce the size of our LV. For first, let's extend our LV size furthermore. So for that, you need to execute lv extend. I want that the size should be extended up to 30 GB of my LV1. Okay. So you need to execute this command. Just again resize it. So it has a file system ext2, that's why I'm here executing resize 2fs. Okay, and your LV path LV1. So we can execute df-h to check the size. So as you are able to understand, our LV1 size is now 29 GB. Now we will going to reduce this LV1 size. So for that, first you need to unmount this LV. So for that, we need to execute the command umount dev my vg lv1. Execute df-h. see, it has been you need to execute lsblk, because when we execute df-h, so whole lv has been removed from this df-h, because it refers for the mounting point. As we have removed the mount point, that's why it is not come under the output of df-h command. We can check it by executing lsblk command. So as you can see, your lv1 has been unmounted. Okay, mount point is not there. Now what we will going to do, we need to execute a command ec2 fsck hyphen double f and your lv name, lv path. Wait, sorry, okay, by mistake I have executed ec2. You need to execute e2 fsck. Okay, so now it has been reducing its size. Just execute resize to fs and your path. Okay, execute lsblk command. So as we are able to know that now its size 31 GB. Okay, we have able to unmounted it. After that, to reduce its size, we need to extend a command called lv reduce. How much you want to reduce it? I want that its size should be reduces by 15 GB. 15 GB. Okay, and just write the path of your lv. So it will ask for the confirmation. Yes. Now just execute lsblk command. So here you will be able to see. So its size is now 16 GB, which is from 31 to 16. If you minus 31 from 16, so it will be 15 GB. So you have reduced the size of your LV of 15 GB, which is of 15 GB. Okay, so that's how we will able to reduce the size of our LV. So I hope you are clear with that much. We can even execute two simple commands to extend or reduce the size of LVs. This is these simple commands. Okay, you do not need to execute that much complicated commands. You can execute simply these commands as well. For that, you need to execute lv resize. How much you want to resize it, you just need to execute this resize hyphen capital L and write the size. So I want that my lv should be about 20 GB. Okay, and write your lv name. So I'm saying lv1. So it has the space, so it will be reduced. Okay, now you can check it by lsblk command. So as you can see, it is now 20 GB. Okay, you can even reduce it by just execute the same command lv, just change the value of your size lv hyphen L, and I want now it should be 10 GB, so it will change to 10 GB. Define the path of your lv, lv1. Ask for the confirmation. Yes. So when it is the time to reduce the size of the lv, it will ask for the confirmation, but for the extend option it will not ask for the confirmation. Okay, so be clear with that much. So you can check it by executing lsblk command. So as you are able to see. Okay, so these two are the simple commands to extend or reduce the size. You can even execute these commands. Okay, these are somewhere complicated. Okay, so basically this is our lecture and the part 5 of storage management. I hope you found this lecture helpful, and for more updates and for more videos on Linux, do subscribe to our channel Technical Cloud Knowledge and keep tuned, keep connected and stay tuned with me. Thanks for watching.